Ratnasagar is one of the largest and most renowned publishing houses in India. The organization is named after a library of Nalanda University, which flourished over 2000 years. Founded in 1982, the brand Ratnasagar represents exemplary standards in publishing. Our books are carefully written by eminent educationists and designed by a team of experts. The book makes learning an interesting, creative, and fun-filled experience. In our endeavor to support teaching fraternity, we host nearly 2,000 teachers professional development programs annually. Our organization boasts of impressive pool of academics who conduct these programs on a vast range of topics. Today we are presenting Math and Beyond. Just a little housekeeping before we get started. If you have any questions during presentation, please type them into the chat box. The presenter will bring them up during the webinar. Now, without further delay, we will turn the time over to Mr. Vivek, the resource person today. To introduce Mr. Vivek Kumar, I would like to say two things about him. And these are the only two things I know about him. He knows math. Number two, he has three eyes. Okay, two are normal eyes, and the third one is the mathematical. We are sure this session enlighten many new aspects of math teaching. Now it's over to Vivek. Vivek sir, please welcome.
Thank you so much, Vipin. Thank you for this wonderful introduction. Good evening, teachers. I welcome you all to this webinar. I hope you are healthy and safe. I really would like to congratulate you all the teachers actually across the country for keeping the pace of education during this COVID-19, for keeping the students engaged academically positively. Now you have proved that teachers can make anything possible. You have truly proved teachers can make anything possible. So thank you so much, teachers. We are proud of you. And today, I am very much hopeful that we all together can make this webinar a very successful one. So as you can see, the topic today, which we are going to talk about, is maths and beyond. So what exactly we are going to talk about, let me brief to you before we start. So I have some different point of views today, and I hope it will help you to a large extent. So I have actually listed some questions, and I'll take you through this webinar on the same lines. So I'm just going to share with you those questions, and during the session, we'll keep on thinking about those questions. So the first question is, should we go beyond? Should we go beyond our understanding, our own understanding of concepts of mathematics? Should we go beyond our own understanding, or should we stick to our understanding? Obviously, not in all the cases, but to some extent, in some cases, we have to see this. The second thing, should we go beyond our understanding of, I repeat, our own understanding of the process of learning, right? And the third is, should we go beyond just ticking the answers, crossing out the answers, or marking, giving scores to answers when it comes to assessment in mathematics? And should we go beyond the language which we use in our classroom to explain mathematical ideas to students? Should we go beyond the language that we have been using, or should we stick to the language, the kind of words that we have been using? So these are some of the aspects we'll see, and I would like to request all of you during the session, whenever you feel like asking, giving any response, please write it in the chat box. We'll take care of all those queries and responses. I really would seek your support in making this interactive through the chat box. So let's start. I have one very simple question that is just for, in a sense, just a kick start of this session. So very simple and very easy question. Get ready to answer, and I expect you answer in the chat box quickly. So here it comes on the screen. So first, my question, and then based on this question, I'll ask you one question. My favorite question here. Do you know counting numbers 1 to 100? I just want to know, 1 to 100. And I know that you know the counting numbers 1 to 100. Now, my first question here today to you is, if you count from 1 to 100, how many sevens do you find on the way from 1 to 100? So when I say 7, when 7 as digit, so how many sevens? Definitely more than 1. So how many times do you find the digit 7 from 1 to 100? Write your answer in the chat box. Wow, 11, lovely. 22, we got 10, we got 14 sevens, we got 19, 20, 22, 11. Very active teachers, good one. 20, 18. Right, you could see there are some, different types of answers. Somebody says 11, some of you are saying 20, 22, okay, great. So thank you so much for your response. I just want to tell you what exactly is the correct answer. The correct answer for this question is there are 27s. So if you count from 1 to 100, you find the digit 7, it comes 20 times. And that's great. Many of you have written it correctly. I'm not saying those who have written it incorrectly, any question mark on them, but there is one thing which I just want you to request. It's not only a set of about 100 numbers. It's about a set of 100 numbers, and then to find out, some mathematical ideas, some concepts based on the set of 1 to 100 numbers. So we will see the concepts from this point of view as well. We'll see it differently. Thank you, teachers. Still, your answer is 20. It is correct, right? So because we have, 2 sevens in 77. So that becomes 19 plus 1, 20, right? If I ask you how many 8s 1 to 100, how many 8s? The answer will be definitely 20. But you do it later on. You do it later on, not now. How many ones do you find? How many times the digit 1 do you find from 1 to 100? How many times do you find the digit 0 from 1 to 100? So it's like, observing and finding out something of the use. Now, the next thing is, let me share with you. I'm going to ask you 2 questions, which are definitely my favorite questions. So there is a fill in the blanks. Where there is fill in the blanks dash, there is a way. Can you just fill it? Where there is a way, there is a will. Okay, good. Very good. Where there is a will, I'm so happy there is a will. Okay, so you all know the answer, right? That is where there is an idea. Somebody has written where there is an idea. Wonderful. Okay, where there is a problem. Okay, where there is a ray. Good. All different sort of answers. Means you think differently, you come up with different answers. Where there is a hope. Nice one. Interest, determination, so many things. But now what I want to, do it today, I want to say where there is mathematics, there is a way. Because, mathematics is everywhere in your life. You grow with mathematics, you live with mathematics. Mathematics is a part and parcel of our life. You talk about any profession, you say, you name anything, you find there is a mathematics. There are some concepts, involved into that. So if mathematics is actually a part of our day-to-day life, if actually it is a part of our day-to-day life, why not make our children, why not make the parents of the children to understand that this is a very important thing in our life? And if it is important, it has to be with us. We have to live with this mathematics. So why not let's talk about how to learn mathematics, how to learn that. So then again, one more questions for the teachers. So again, this is a fill in the blanks. Now, we know mathematics is everywhere in our life. Now then, how to learn mathematics, right? So the question that is here for you is the only way to learn mathematics is to dash mathematics. Okay, practice, use, do, explore mathematics, okay, enjoy mathematics, understand, love mathematics, play mathematics, good. Lots of lovely, and all definitely correct answers. But my point of view today, I really want to emphasize on one very important aspect here is the only way to learn mathematics is to, some of you have made it, the way I think that way. The only way to learn mathematics is to do mathematics, is to do mathematics, is to let the students do the concepts, let them explore the concepts, let them enjoy the concepts by doing, let them experience, let them identify the patterns, let them identify, the pattern, and then construct their own ideas, the mathematical ideas, right? We truly start with, when we talk about teaching mathematics, especially when we start with counting numbers, addition and subtraction, we do, make our students to perform addition, subtraction, or counting by using the real objects. So we make them to do addition, we make them to do counting, right? But my point is, mathematics is not actually difficult. We all are maths teachers, we all are into maths, teaching and training. So we all know mathematics is actually not a difficult subject, but somehow it has earned a reputation. It has earned a reputation of being difficult subject. You see, most of the students, they have a maths phobia. When I interact, I feel sometimes it's not their fault. Somehow something has gone wrong. Either maybe, the material that they have been using, the textbooks, or maybe the way we have been explaining them. So we need to see it from that point of view. Yes, they don't have a clear concepts, I do agree, but the concept will be clear. And it's, mathematics is not about writing answers in the notebook, doing questions on the board. It's all about applying, it's all about the application. So then when it comes application, we really work hard. I know you all teachers work hard. You design, your lesson plan, craft it beautifully, and deliver it wholeheartedly. Even then, what happens, what goes wrong? So we will see it from, today in a very different point, from a different point of view. I'll show you some of, so these two things we'll first keep in mind. And then my one request to you, which I always do, which I always make to all the teachers when it comes all about teaching of mathematics. Yet it is applicable to all other subjects, but today we are talking about mathematics. The first thing is very important. Suppose today you are going to teach a concept, which is, you are going to do it for the first time. Suppose you are going to introduce it for the first time to your students. So it means your students, they have no idea at all, no idea at all what, the concept is. So the point is, when, because you are teaching it for the first time, you need their attention, and probably you feel their attention is very much required. And to get their attention, sometimes, I do not know anything about the way you have been teaching, but sometimes I feel some of us, we make a statement like, if you want to understand the concept which I am going to teach, my students, please pay attention. Why? Because the concept which I am going to teach is a difficult concept. You will be able to understand only if you pay attention. Or maybe it may create confusion. It may be a confusing concept, so you need to pay attention. The moment you tell your students that this is a difficult concept, if you want to understand, you pay attention. Now see, the students have no idea at all whether this concept is easy, interesting, boring, or difficult. They have no idea at all. But they have one sure sort of the idea that my teacher is an expert of this subject. And if the expert of the subject says it is a difficult concept, it is a difficult concept. They take it that way. So probably when we see it is a difficult concept, or some subject is a difficult subject, what we are doing, we are trying to frame their understanding. We are trying to frame their thinking. And with that framed thinking, they will move ahead, which they will not be able to, do. They will struggle. So my point is, please avoid saying anything which can frame their thinking negatively. I mean, which can create obstacle in the path of learning of this subject. So my request, never to say that it is a difficult subject. You want attention, your objective is very clear, but we need to find some other way to make it. Some other way to say that, this is a very interesting concept. You will enjoy if you understand it, right? So this is request number one. And then let's go to the next thing, the introduction. The introduction means the day when we are going to introduce any concept for the first time to our students, we need to prepare it exclusively. Because during the time of introduction or after the introduction class, that the class of 30 or 40, 45 minutes, this introduction may lead to some misunderstanding or may lead to some, understanding. So we need to be very careful while designing, crafting our lesson for the introduction class, so that they do not struggle in the very first day. Because if they struggle in the very first day, it may hamper their learning, their interest in the next day. So the preparation, the homework should be done very carefully. And if you can keep in mind the misconceptions which the students of the previous batch, if we have taught to the same class last year, if the students of the previous batch had the misconceptions which they had after the teaching, or after a month or two of the explanation of the concept. So if you can keep those misconceptions in the mind and prepare yourself in such a way that the current batch do not get the misconceptions, they get only the understanding, the conception, the true mathematical conception, then it will be easier for us to prepare our introductory class. Now, two things very important today. I started with that. So do we speak mathematically in the classroom? So now I'm slowly and gradually shifting to the real examples, real concepts. So I'll take one or two aspects of some concepts and we'll discuss about it. And I would like to point out the aspects which we need to be very careful about. So do we speak mathematically while explaining a maths concept? Now it means, my point is, do we use the language, of mathematics to explain a concept of mathematics? Yes. So your responses I could see. Thank you so much for being very active participants in the session. Not always, mostly yes, not necessarily yes, no. So thank you so much. It all depends. This varies actually from teacher to teacher, but I want to, emphasize and raise this point today. So, and the point number two, when we talk about teaching of mathematics, there are two types of knowledge involved. One, it's the knowledge all about the concept, knowledge of concept, so conceptual knowledge. Second comes is the knowledge of procedures. So where do we emphasize mostly? Do we give our students procedures, or do we also, give them the understanding of the concept? I'll take some examples and we will evaluate ourselves. And let's see if we are able to find out something, new in today's webinar. So whether conceptual understanding is only important or procedural understanding, or both, either of one impacts the other one that way, right? So yeah, someone is saying, that both are important. That's true, actually. So let's go. I'm going to take one concept, and please have patience and answer my question, right? And listen to me carefully, because this is not actually a live, training where I could write something, could expect you to come and do something. So we'll do it keeping that in my mind, in our mind. So here is something written on the screen. I'm going to read it out, and I request you, please tell me whether I'm reading it correctly or incorrectly, right? I'm just going to read it out. 124 divided by 2. I'm not expecting the answer. Just let me know the way I read it. 124 divided by 2. Is it correct or incorrect? So some of you are saying incorrect, some of you are saying correct, right? Now, please understand it very carefully. It's not 124. I'm talking about reading or speaking mathematically. It is 124. It's not 124. Because if you say 124, it means 1 times 24. If you say 224, it means 2 times 24. Right? But it is actually 124. And let's see the the loss when we read it, 124. So when you are reading it as 124, you forget, including in the place value of 1 is at hundreds place. So when you read 124, I hope we all understand, we all have been struggling, facing, our children, they struggle a lot with with the place value systems, right? So we need to read it correctly, speak it correctly. 124 divided by 2. Point number 1, right? Number 2, think of all the 4 operations: addition, subtraction, multiplication, and division. Addition, subtraction, multiplication, and division. Except the operation of division, the rest, all 3, when we perform addition, subtraction, or multiplication, we start from right side. The progression is right to left. But when we perform division, the progression becomes left to right. We start from the leftmost digit. So a question that comes in my mind, why? Why only division from left to right, rest all from right to left? Point number 1. Number 2, and let's see whether we all have the concepts, or not, or we have just, been doing programming. Okay. So if I ask you, if you have pen and paper, feel free, if you have pen and paper, you can try. Now, I don't want you to divide 124 by 2 by starting from the left side. Let's actually try dividing 124 by 2 and start with the rightmost digit, that is 4. And then you tell me your answer. Whether it is possible to get the answer, we all know is 62. So is it possible to get the correct answer, 62? If we divide from right side, is it possible? Just try. I just really want to discuss something which will open our third eyes today. No, no. Okay, no. 2 comes, it's not possible, right? So the answer is 210, beautiful. Okay, no. 21.1 is the answer, which is wrong. Okay, so 62 is the correct answer, and we are not getting 62 when we divide from right. Now, listen to me carefully. Dear teachers, listen to me very carefully. Now, when it comes about concept, I'm going to do it for you because I cannot write it and show it to you. Please pay attention. I'm going to do it for you, and let's see whether the answer comes 62 or not. So I'll relate it with the real life situation. So let's say if there are 124 sticks. If there are 124 sticks and we have to divide it by 2, it means I want to make bundles of 2 sticks each. So how many bundles? If we divide it from left, we could say 62 bundles will be there, right? So 62 bundles means with 2 sticks each. Now, if we start it from the right side, so I have 4 sticks first, 4 in the ones place, 4 sticks first. And I want to divide 4 sticks. I want to make bundles of 2 sticks each out of 4 sticks. So how many bundles will be made out of 4 sticks? 2 bundles, 2 sticks each, right? So we have got 2 bundles. Done with the 4. Now let's come to the next digit, that is 2. So 2 is at 10th place. It means 20 sticks because 24 means 20 plus 4. Now we have 20 sticks and we have to make bundles of 2 sticks each. So out of 20 sticks, how many bundles will be made? 10 bundles. So 10 bundles and 2 bundles we had already made, right? So 12 bundles. Now let's go to the last digit, that is 1, which is in the hundreds place. So 100 sticks. Now you have 100 sticks. You have to make bundles of sticks with 2 sticks in each bundle. So how many bundles will be made out of 100 sticks? 50 bundles. 2 sticks each, 50 bundles. So 50 bundles plus 10 bundles, 60, and plus 2 bundles. This is 62. Did you get the correct answer? Now here it is all about understanding of the concept. It's not about whether you do it from left side or whether you do it from right side. It's all about whether we have understood the concept or not of division. It's not, and then why do we divide it from left side? That is another question, because it becomes easier for you. It saves your time. So because speed, we also need to see that time, if we are able to save it. So my point is, first, my request to you, please speak mathematically. Use the language of mathematics to explain, to talk about any concept. I'll give you 1 or 2 more examples. Then second is, let's focus more on the conceptual understanding instead of procedural. So once the concept is clear, then we can move ahead and go with the the knowledge of procedure, how to do it. And let me move further. I'll take even the example of simple counting numbers, and we'll see how we can take some more things today from this webinar. So this is, I hope, is clear. Let's go to the next slide. One more concept. This is, I hope we all have seen, this is a number line, right? Thank you all the teachers for your response. Yeah, I can do all these questions, right? 416 divided by 60 divided by 7. Okay, you all can do it. You do it on your own, even with remainder or without remainder, you will be able to do it. So this is the next concept, that is number line. I'm just giving an example, whether we speak mathematically, whether we emphasize on concept, or we emphasize on only procedures. So it is a number line. Now my question to you, and then I want you to write your response in the chat box. My question to you is, which point on this number line, so there are some points like A, B, C, D, E, F, G, H, right? So which point on this number line, the number line which is on the screen, which point on this number line indicate -3? I want your response in the chat box. Which point on this number line indicates -3? Wow, beautiful. I'm really happy. C. So it's like all of you have given C and 1 is D. My question is, which point on the number line indicates -3? Right? Okay, so mostly C. Great one. Thank you so much for your active and very positive response. Okay, now let's focus here. You cannot, and let me justify, right? You may find it for the first time. You cannot show -3 on a number line. You cannot show -3 on the number line. You cannot show -9, -5, -3 on any number line. But yes, you can show -3 on the number line. You can show -3 on the number line, right? It's not -3, it's -3. We all know that number line is all about positive and negative numbers. So my point is, when we use the language of mathematics, it should be mathematically correct every time. And you can do it with your students. You do it with your students, this particular exercise, they will never forget it, that -3 cannot be shown on the number line. They will remember forever, right? One more example, one more concept related to this, so I'll be taking just few concepts. I can take whole lot of 7-8 hours on integers, on decimal, fraction, and every other concept. But today we have just 1.5 hours, so we'll be doing it this way. So maybe 1 or 2 aspects of each concept. Now see here again, there is one concept. So it is write the expressions, right? So we have 2 expressions, mathematical expressions, 1 and 2. So can I request you to write the first one? Let's start first with the first one. Yeah, please avoid, I say, please avoid reading it to -3. You can never show -3, -5, -9 on number line, because whatever we speak, whatever we say, it gives either a conception or it gives a misconception. And in mathematics, because mathematics is a subject, I'm not expecting answer. I just want you to read the expression. So then you could read the first one as 8 minus 3 or 3 subtracted from 8. But in a very simple term, where we use minus, so it's like 8 minus 3. Second one, if I want you to read the second one, so write in words the second expression. Write in words. I don't expect the answer. I just want you to write the expression, second one, in words in the chat box. I say words, 8 plus -3. Yes, true. Somebody has given Prachi, thank you, Himani, I think, yeah. So it is 8 plus -3. It's not 8 plus -3. I still remember, my school days. I hope you all must have, came across with this. So there were like operation of integers, means there were 4 rules that were, shared with us. So it was like plus, 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 minus, minus, plus, plus, minus, minus, and minus, plus, minus. No, it is not plus, plus, or minus, minus. It is positive, positive. So, when you add 2 positive numbers, it gives you another positive number. It's all about, positive number and negative number. It's not about minus, plus. So my request today, and if you really want to see a change, please, if you can make it a habit. So there is a difference between minus and negative. So minus or plus gives you instruction, command, what to do. So add, right? A child comes to you and say, ma'am, what to do? So then you tell, because you see this is a symbol of, subtraction. So it is minus, you subtract. It is a command, minus or plus. But when it comes about positive or negative, it does not give you any command. It truly does not give you any command. It but tells you the value associated with that number. In a very simple example, which I normally give, in my sessions, like, have you ever heard about he is a plus boy? No. Or she is a plus girl. So he or she is a positive girl, a boy, or teacher, or whatever. So what is the point? Because the word positive tells you about the characteristics. It talks about the value associated with that. So if a child does not know the value associated with the number 3 here, how will the child perform the operation? So 8 is added to -3. And then there are many other concepts which we need to see, which we need to be very careful about, especially when we introduce any concept in the classroom. And especially for integers, number line, integer comes later on, right? Let's do with the number line, which you do in classes 1 to 5. So I say first, the best example I give from the day-to-day life is a scale, a ruler. So, there are some students, they get confused which side is the positive or negative side on the number line, even later on. So better is to draw a big ruler, make it of a chart paper and paste it in the classroom. A big number line. You can make the students, right? You can make the students to do it. So under your guidance, so you be the guide by the side, not the sage on the stage, and let them do it. So once they do it, they will remember at least some aspects of the number line, right? The progression and all. So moving ahead, These are some of the 2-3 concepts which I thought of sharing, where we truly do not read, mathematically, we do not speak in the language of mathematics. And see, there is one aspect which I would definitely love to discuss, but not now, later on, that why do our students, they struggle with word problems? I hope we all agree that they struggle with word problems. When it comes about doing sums in the column method, they are very good at, probably, but when it comes to the word problem, they start struggling and they have got that phobia of word problem. And we all work hard to remove, to help them to get rid of the phobia, but we are not able to do that, right? So we'll see, and what we need to do then, how we need to go beyond the way we have been doing. We have been helping them to do word problems. We'll see that also. So let's go. So there's nothing like minus plus, numbers when it comes about to negative positive numbers. Okay, introducing counting. So let's start with this first. I'm going to show you how do we introduce counting. So I this is my favorite activity which I show to the teachers. So if some of you have attended my session previously, could relate. So can you say there are 4 markers, right? The first one is blue in color, second black, third is red, and the fourth one is green. So I have 4 different colored markers. I have taken these colors, 4 different colors intentionally, because I wanted you to see it from, a distance, through online, that these are 4 different markers. Now I'm going to introduce, and let's do the self-analysis, whether we do it in our classroom this way or not. So I'm going to do it here, and let's pay attention. So I'm going to teach, let's say my child or students, counting up to 4. So how do I do it? I touch the first marker and say 1, 2, 3, 4. We touch the object and we keep on saying 1, 2, 3, 4, 5. So you touch and you say a word. So I do it again. 1, 2, 3, 4. 1, 2, 3, 4. So you did it twice and thrice. And then suppose if you ask a child, give me 2 markers, give me 2 markers, the child may give you this one, the black one, the second one. Why? Because you read it 1, 2. You touched it twice or thrice and you said the word 2. And then you ask the child, oh, give me 2 markers. The child may associate the word 2 with the name of the object, right? With the name of the object. So what to do in that case? This if it happens, it is yes, I truly feel this is wrong. We should start with the objects when it comes about introduction of, introducing counting, the concept. What will actually help students to do it? What will help them to do it nicely and to be able to make them to develop a skill or ability to count is to start with concrete real life objects. So let's say these are the 4 objects which are real life objects, the real objects, concrete objects. But then what is wrong into that, right? It creates confusion in the mind of the child. This will become more clear if I ask you one more question. 0, and then we'll relate. 0 is, something which we all know about. So if I ask you to write in the chat box, what do you understand by 0? It's very simple in the common man language, from the point of view of children, or what do we understand by 0? 0 means nothing, no value. So nothing means absence of something. So I had 3 pencils and I gave 1 pencil each to 3 different children. So I have left with no pencil. So it's like nothing left with me. Okay, I agree. Very good. Nothing. It depends on its place value. That's good. But I'm talking about only 0. So what does it mean? Right? So it means normally, okay, nothing. Now I give you one example, and I'm really sorry to give this example, but it's so interesting that will remind you, you will always never forget this, concept which I'm going to talk about. The room where you are sitting and attending the session, if I reduce the temperature of the room to 0 degree, will you still say 0 means nothing, means 0 degree temperature means no degree temperature? Will you still say absence of some temperature, 0 degree temperature? We just saw a number line, and a point on the number line indicates 0. Yes, degrees attached to it. So no object, so always there is one object or something, because we used to count, the objects which are numerable. So definitely we use some word after that. So now my point is the point 0 on the number line. So suppose if I am standing on the point 4 and you ask me to jump towards 0, 4 steps, I'll reach to 0. Did I reach nowhere? I reached somewhere. Give you another example. There is a concept of 0 figure in, media. 0 figure, does it mean no figure? Yeah, it had some value. Now let's relate it from this point of view. So I'm going to tell you what exactly we need to be very careful about. So 0 or any number, let's say 5, 7, 13, 57, 25, 63, 124, whatever, can be used in 2 different senses. Now, number one, when it is all about name of anything, it becomes noun. So name of a degree is 0 degree temperature, 0 degree, name of a degree. Name of something is noun. So when a number is being used as a name of something, that is noun. When it is all about, we are using as I had 3 pencils and now I have no pencils left with me. I have given 3 to 3 different children, so nothing left with me. Then we are talking about the quality of the collection that I have currently. So if I have 5 pencils, so 5 is the quality of the collection of pencils. The quality of this means the size of the collection. So then here we are talking about the quality, right? Quality in this terms means the size, the volume, and definitely that is the quantity, 5, 7, or 9. So it is used here as an adjective. Now keeping these 2 things in mind, right? So it is all about the quality of the collection, and quality here about it's all about the size of the collection. So what is the size? There are 5 people in a group, or maybe there are 9 people in a group. So the size of the group is 5 or 9, and the size means the quality, right? Because we then compare it that way. We'll see it. Let me go back to the concept counting number. So what we actually need to do when we start, when we introduce counting numbers. So first is to show them some objects, use real objects, concrete objects for them. And while showing them, let's say if we are going to talk about 2, we're going to teach the number so-called 2. So then you show them 2 objects, 2 different objects again and again, or even the actions like 2 pencils, 2 boxes, 2 chalks, 2 boys or 2 students, 2 claps, 2 jumps. So actions or objects. But while showing them 2 objects or actions, every time we will say, we will emphasize, we will stress on the word 2, right? And we keep on at every stage ask question like, how many markers do I have? Now I take 1 more. So now how many markers do I have? So this way, use the language. I say spoken language. The more you use the spoken language while giving them the exposure, and then when they experience on their own, when they do with the concepts, when do activities based on some concepts, by using real objects, even we need to encourage them to speak up, to share with us what they are doing. that will enhance their understanding overall, and that will help them to apply the concept, and they will not even struggle in the word problem. So the spoken words should be used in the very initial stage of, instead of just writing the numerals. If I ask them, if I ask you, what should we introduce first, numeral or number? Numeral or number, which should be introduced first? Should we introduce first numeral or number? Numeral is the symbol, right? So when you write in numeral or the number, your responses vary. I feel numeral means the symbol should be introduced only after an understanding, to an extent, an understanding of the concept number. Because when you are introducing number, I say start with the real objects. So 2 pens, 3 pens, 5 pencils. So when they understand, then you write, you use different objects, different actions. So how many times did I jump? How many pencils do I have? So I had 3, I pick one more. Now how many do I have? This way. So first should be the number, and then you can write on the blackboard or green board 3 inverts, THREE pencils, 3 pencils, and then you can associate, instead of writing 3 inverts, you can then replace the word 3 and with the symbol 3, the numeral, then 3 pencils, slowly and gradually. And even instead of introducing the symbols of addition, subtraction and all, we should first start, using the spoken words at least. Why I emphasize on spoken words? Because they are small children. So spoken words, so 1 pencil and 1 more pencil. So you write on the boards after, you repeat this many times with some objects, some actions. And then once you feel they are okay with that, then you write it on the board, 1 pencil and 1 more pencil and 1 more pencil, right? So that will, then you can replace it with the symbol of addition. And second, when we use objects to count, there are three actually pre-number concepts. Number one, ordering, because we are talking about introducing the concept of counting by giving them some objects, right? So what first they need to learn to do, to an extent, before we expect them to count, is to place the objects given to them in order, in an order. Number one. So ordering is one pre-number concept that is very much required. Number two, once they have placed the objects, let's say you give them 5 pebbles, you give them some, 7 objects. So they are okay, they are good, to an extent in placing the objects in the order. Then what you could do? Then the second pre-number concept that is important for them to understand is the classification. The classification means, let's see, there are 17 objects, or let's say 7 objects placed in an order on a table. So the child should be at least, familiar with, to an extent, the concept of classification, so that the child could classify the objects into 2 different categories: the objects which he has already counted and the objects which he still has to count. Otherwise, what happens? Some children, they get confused because they have not placed the objects into order. They have not placed the objects into the order. And if they are not classifying, keeping the objects which they have already counted to one side, and the objects remain, which are to be counted, still to be counted on the other side. So if this classification is not happening, they may get confused, right? So like if there are 4 markers, I need to classify. I have placed these objects in an order. I need to classify. Okay, 1. So if I have counted this, I need to keep it one side so that, I do not get confused. So this one has already been counted and these 3 still to be counted. So the classification then is very important. First one is ordering. Second one is classification. Third one, you ask any girl child or a boy child who knows very clearly and is confident enough to tell you verbally, orally, the counting 1 to 20. If a child who is good at, telling you the counting numbers 1 to 20 correctly, does it mean the child knows counting the objects as well? So the best way to check it, number one, whether the child is able to place the objects in the order, whether child knows classifying. Number three, very important, is, see, let's say there are, the child who knows 1 to 20 counting. You ask the child, you go and get 9 pebbles from a collection of pebbles in a box. The child may give you the correct 9 pebbles, or may give you less than 9 or more than 9. Now, what point here is, okay, so I'll share it here. What point here is, now when I say 1, so what I'm doing, touching the object and doing the classification, keeping it one side, right? And saying a name. So when I say 1, so saying and touching, so 1-to-1 correspondence. So let's say there are 9 pebbles I have to count, and the speed of saying the number, the counting, is faster than the speed of touching objects, right? So I speak faster than the speed the way I touch. So then what happens? The child will not get the actual correct answer. So what is the point? The point is, first, keeping the objects in order. Number 2, the child should be able to classify the objects, the counted objects and still to be counted objects. Third, the third one is 1-to-1 correspondence. So touching it and simultaneously saying it. And one very important aspect of this counting number is, when we introduce, do it this way, it will help to a large extent, later on. So do one thing. So let's say these are the objects, whether you have placed or you are showing it by keeping the objects in your hand. So you touch it and say 1 marker. This is 1 marker. I take 1 more marker and move this marker towards the first one. You are also classifying. So now this was 1 marker. This is 1 more marker. You move it. If you have kept it on the object, if you are making the students stand in a row, then you can move one child, towards the one side, and then second, when you say, okay, 1 more child, so now we have 2 markers. So that will, give you a wonderful concept, which I find sometimes students, they struggle, and I really feel very, very, very sorry for this. So what is that concept is, they will also slowly and gradually understand the word 1, 2, 3 or 4 is not something which relates to name of an object or action, number 1. Number 2, it is associated with the size, with the number of actual objects. Number 2, very important, slowly and gradually they will develop an understanding that the subsequent number is 1 more than the previous one. Subsequent number is 1 more than the previous one, because every time when you say 1 marker, I take 1 more marker. When you use 1 more, it makes it bigger. It's make it bigger in size. Again, you say, I take 1 more marker. So what gives an understanding to them, gives them an understanding that every other, the next name, the next number is bigger than the previous one. I'll show you one slide, where it comes all about smaller and bigger number, smaller and bigger number. So how do we, I find it very simple. You can do it. Please do it with, it's like, how do we introduce smaller and bigger number? So I'll show it to you here. So now if I ask you which one is bigger, you just write 1, 2, 3, 4, 5 on the blackboard, and you see the font size is same. The size of the numeral same. So if you write it, you ask the students which one is bigger. Yeah, we expect them to say, nah, 5 is the biggest. right? 2 is the bigger than 1, 3 is bigger than 2. But then my one request to you, if you can show this to 1, I hope you agree. Instead of just showing them 1, 2, 3, 4, 5, let's show them 1, 2, 3, 4, 5. This way, the size increases, the volume increases. 5 here is the biggest one. And you repeat this activity, sometimes they will develop an understanding, they will get this understanding, in consecutive numbers. The first one is the smallest one and the last one is the largest one. Slowly and gradually, all these help students to understand the concepts. My very simple request here is to please plan it such a way they could find it easy, they could find it interesting to look at the screen, to look at the blackboard, to do something what you expect. So that way. Okay, so now moving to next, communicating addition. So I'll just take one small aspect I just want to highlight here, and then we'll move on. So I'm going to show you some slides. So 3 slides at least. And I request you to observe the slides carefully and then write your observation in the chat box. I'm not expecting like everybody will write everything, but yes, togetherly we can write many things. So here it goes. Look at the screen carefully, right? So these are toys. I should add this much. So 2 and then 3. So 2 toys and 3 toys. Next, look at this screen. I would not add anything here. Would request you to the third one, final one. Right? Now I'll go back, show you again all these 3 slides one by one. And then I request you to please write your response, your observation in the chat box. Second slide. And the third one. Now write your response in the chat box. Your observation about these 3 slides. Okay, same numbers. Good. Same number. Okay. Expecting more teachers. Right. So now let's go back, and I would request you to practice this once. Okay. So every time you see on this all the 3 slides the same addition fact, 2 plus 3, same addition fact, 2 plus 3. Instead of teaching first 2 plus 3 and then 1 plus 3, then 2 plus 1, no. I have made it very carefully. So whenever you introduce any addition fact, so first stick to that addition fact. Use different objects. So my point is same concept, 2 plus 3 is equal to 5. Same concept. So same concept, different objects. I have used different objects. And I have also used different arrangement of objects. So objects on all the three slides are not arranged in the same manner. Here you could see the objects, the way the objects have been arranged. Here the arrangement is different. Because what happens, even if you are writing on the whiteboard or green board, if you are drawing 2 circles and 3 circles, please avoid doing it always in the same pattern, in the same arrangement, like drawing 2 circles in the straight sleeping line style, and then again 3 circles in the sleeping line style. Can we change the arrangements? Because we do not get always objects in the same arrangement. We have to see it from the point of view it has been given. And then otherwise they also associate the number or the answer with the arrangement sometimes, that particular arrangement of objects. So here what I'm trying to teach, my point is repetition of the same addition fact by using different objects, different arrangement of objects. And child should be, then if after explaining you are giving the child to count 2 and 3 objects, 2 plus 3 5 objects, so then in that case the child should be encouraged slowly and gradually to let to share with the whole class that what he or she is actually doing. And what is common here, my point in all these 3 slides, what is common here is fiveness. So 2 and 3 means 5, right? So fiveness is something which is common in all the groups, all the operations, all these 3 operations. So you need to also emphasize on that fiveness, sixness, two-ness. Slowly and gradually they will understand they would identify themselves, they will find that pattern and they will construct their own understanding. Building upon that will be then very useful. So the language we need to use the spoken language. I'll show you one slide, the formula, how do we need to go that. And then slowly and gradually you can ask the child to speak up and say that 2 toys and 3 more toys make 5 toys. And then slowly and gradually we can introduce the word add all together, plus, and then finally the symbol of addition. So this way if we do, it creates a strong foundation. And if you are using the spoken language to describe, if you encourage a child to use the spoken language to describe, it means you are introducing the word, the problems, the statements, the concepts in the word format at the very initial stage, and that is the requirement. That is the need of the hour. Otherwise, they will keep on struggling with the word problems. I hope this much is, and this is just one point which I wanted to, emphasize here, not word problems. So maybe one of my favorite topics where I would like to discuss a lot. But yes, keeping in mind the time, I need to put a cap here. So word problems. We all know the students, they struggle with word problems. Most of the students, they struggle. The moment you give them word problems, they start looking here and there, right? So then what should we do? Before we discuss that, let's discuss why do they struggle with the word problems. And let me explain it to you. Please, if you agree, I request you, go back, whether you are teaching online or you will be teaching definitely offline one day. So please keep this in mind and avoid practicing. So my point is, should we go beyond the way we have been teaching, beyond the language that we have been using, right? So here it is. I first found it in the case of my daughter. I saw, her struggling. Okay. I thought over that. Then I came to know that in classrooms, when we teachers, we find students struggling with word problems, we truly want to help them. We truly would like to help them to be able to solve word problems. So-called, we do not, and how do we help? We help by saying, beta, if you find a word total in the word problem or the story sum, it means you have to add. If you find a word remaining, it means you should subtract. Now what happens? This is what the remediation given by the teacher to that particular child. And the child, since he or she believes, trust the teachers, so he or she starts looking for the words total or remaining. And because they are very young children, they look for the word, like I have 5 objects and my sister has 3 objects. So how many objects both of us have, total number of objects. So then the child finds the word, and if he finds the word total, will add, 3 and 5, gives you 8. The answer is correct. And since the answer is correct, you tick mark, you give score, or you tick mark it correct it. Then the child gets encouraged to use this practice, use this formula to identify the words which can help them to solve the word problems. Fine. But see what is happening. If they have understood that identifying the word will help them to do successfully word problems, they will only look for those words, key terms that you have shared. And if they will look for those key terms, it means they will not read the statements, the whole problem, the whole story sum. They will not read the whole story sum. If they will not read the sentences of the word problems or story sums, it means they will not understand further the language of mathematics. It's all about mathematics itself, a language, and then language of mathematics. So what we are doing, we actually helped them by giving a shortcut trick. So I always say in mathematics there are 2 ways. Number one is to take the easy path, or number 2 is to take the right path. Yet it is applicable in any sphere life, but I say, avoid taking the easy path. Let's take the right path. If they will not read the sentences, they will not understand the context of the word. That is the context. Any word problem is basically a situation, a context of the real life, right? So if they will not be reading the language, the sentences of the word problems, they will not be able to understand the context of the real lives. And if they will not be able to understand, they will not be reading again and again the different contexts of real life where the addition, subtraction, or multiplication is required. They will not be able to apply the concept. And so I say, I always request you to discourage, change your style of giving them, tricks, giving them key terms, helping them by giving key terms to them. So I always request you, please don't do that. So this is number 1. And number 2, why do they struggle with word problems? Because we do not use the spoken words, the spoken language in the very initial stage of introduction of the concepts. You do it for one particular concept, believe you me. You do it with one particular concept with your students, you will find they are very much okay with the even word problems and as well as the application of the concept, right? So these 2 things, we need to use the spoken language to explain the concept, especially during the introductory classes, and we also need to encourage them to speak up what they are doing. So if they are encouraged to share with the class, with you, what they are doing, it means they will also be using spoken language to explain it, to share it with you. So that will help them to a large extent to do with word problems. Next, one aspect which I would like to discuss here. Before that, quickly. So this is what is this? Simply, I just don't want to ask you to write in the chat box. But yes, many times I, hear people saying it as, this is a table of 9. I again request you, this is not a table of 9. This is either you say, again, speaking mathematically, this is a multiplication table. And if you can make it better, this is times table. This is a times table. So this is the times table of 9. So times means, it gives a concept of multiplication. So everything that you use to speak, to name, to share, you write. So we need to make it mathematically correct. Just wanted to share. And one more concept which I really got surprised when I saw a student doing it, in a manner which I was not expecting. So this is a multiplication, right? Performing multiplication, which has been given in the column method. So the number 17 has to be multiplied by the number 23. So 17 multiplied by 23. I would share with you how normally students they do. And if you agree, please write your response in the chat box. Please write yes. If you agree, I'm going to share with you how do normally students, even students of class 5 will do it. 6 will do it, right? So if you agree, please let me know. Share your response, by writing in the chat box. You can write yes. So what they do first, they first multiply 7 by 3, right? So they make it 7 3s are 21, and then 1 they will write here, and then 2 will be carried forward. So 3 1 times, and then this way. So they first multiply the ones digit of 17 by the ones digit of 23, and then this way they do it. Then they go for 7 multiplied by 2, and then 2 multiplied by 1. They write in the second row. Sometimes they put cross. I do not find the use of cross. It is never cross. It is like, multiplying 17 by 3 first. My point is, if a student of class 5 is doing this, he knows and he even remembers that rote memorization has been done so nicely. He remembers the multiplication table of 17. Why does not he or she do it 17 3s are? Why does the child do it 7 3s are and then 1 3s are? And then carry forward and add. If they know already the multiplication table or times table of 17, they can do it simply 17 3s are. They can do it simply 17 3s are. And it's like mathematics has many walls. Mathematics has many walls. But if we are not able to bridge the walls, connect the walls of, the walls means the mathematical ideas are walls in mathematics. So let's say multiplication table is a wall, is a mathematical wall, and performing multiplication in this column method is another wall. And if we are not able to bridge these two walls, we are not able to use the concept which already the children they have. So then what's the use of studying, that in the previous classes? So let's see it even from this point of view. We need to bridge the walls of the mathematics. And I say mathematics has always two ways, forward and backward. I tell you how. Mathematics is all about exchange of ideas. Mathematics is all about exchange of ideas. Rupees into paise, paise into rupees, right? Decimal into fraction, fraction into decimal. Centimeter into meter, liter into, so it's like all about exchanging two different ideas. Even place value is also a concept where a lot of exchange is there. So 10 ones is equal to 110. It's all about exchange. So I have 10 1 rupee coins and I go to a shop and say, I want, instead of these 10 rupee coins, because I have to travel, I want you to exchange it, and give me a 10 rupee note. So it's all about exchange. 10 ones is equal to 110. The best example of, the place value system. So my point, please try to understand, identify the walls and wherever it is possible for you to connect two concepts. And I feel it is always possible to connect one concept with many other concepts in mathematics, because mathematics is a subject which works on the concept of building blocks. Building blocks means you name any concept, that concept is based on or related with many other concepts. Let's say fraction. You want to do fraction, you cannot do it if you do not know LCM, means addition of fraction to unlike fractions, right? You cannot do LCM if you have not studied, you have not, you don't have the command over multiples. You cannot do multiples if you don't know the times table, right? So to an extent, one concept is based on many other previous concepts, and if a child is or has been struggling with one of those previous required concepts, will not be able to do that higher concept, and the child will struggle. So then we need to diagnose. We need to diagnose it. So at every level, we need to diagnose in case of every previous concept, which will consume lot of time of a teacher. So better is to every time keep your eyes, the mathematical eye open, I say, and try to find this, how this is related to something which the child has already studied. And let's talk about it. Let the children to find about it. So a very simple question. I want you to write. So 12,705, we can write it very simple. I don't want you to do this because we have sort of time. So I'm going to tell you one number and quickly write this number in the chat box. Quickly write this number in the numeral form. I'm going to tell you, a number which you will be writing in the numeral, in the figure, in the chat box. Okay. So are you ready? So write the number 11,1111. 11,1111 in the chat box. So write it in the numeral. 11,1111. I'm not able to see the chat box. Any? Yeah. So write the numeral for the number, 11,1111. I'll show it to you on the screen. It is like if you have written this way, 11,1111. It's again conversion because 1100 means 1,000 and 100. So it's like 11,1111. It is again based on the concept place values. It is again based on the concept place values. So there are many things to discuss about, even the place values and all. But I mean, some activities which I could quickly suggest you about place value. First, how would you introduce? Just look at this. Look at this. One apple and one more apple. So it is correct or incorrect? One apple and one more apple make, yes, two apples. Good. Okay. Let's go to the next one. One apple, one more apple make two apples. In the same way, if I replace the word, so ignore the word three in the first line, right? So one apple and one more apple makes two apples. In the same way, if I read it as one and one more one make two ones. So the one which is black in color, it talks about the size of the collection, the number, one number of one number of apples. So one and one more one make two ones. In the same way, like two apples and one more apple make three apples. So two ones and one more one. So this one which is in the red, let's consider it as an object. So instead of two apples, I say two ones, right? One more apple, I say one more one. So the word one which is red in color, let's consider this as object. So two ones and one more one make three ones. We need to establish this by taking many examples and starting with first by taking some objects like two apples and two more apples make four apples. So two ones and then two more ones make four ones. And second is we have 10 fingers. I think these 10 fingers are the best examples with us which we could use to explain the concept of place value. So 1 1 2 ones, 3 ones, 4 ones, 5 ones, 6 ones, 7 ones, 8 ones, 9 ones, and 10 ones. So 10 ones make 1 10. Make 1 10. 10 ones, 1 10. Like 10 coins is equal to 110 rupee, note. So that way. And third, what you could do is to let one child speak any number. Let's say a child says 36. So somebody else, or maybe some other child from the rest of the students will stand out. Either you choose you can make groups and any other way you prefer to do it. But that child has to stand up and say 36 means 3 tens and 6 ones. 36 means 3 tens and 6 ones. So that way, so keep on doing this. Every child will say a number and the other children will say, 3 tens and 6 ones, or 5 tens and 3 ones, 4 tens and 1 ones. So that way, we could go up to the 100 and 1000 this way also. Okay, so quickly, just 1 or 2 questions, then we'll share with you, some feedback thing. So 2 fractions are said to be unlike if I see most of the times what do? We say if the denominators are different. Means half and 1/3. These are 2 unlike fractions. Why these 2 are unlike fractions? Because these 2 fractions have different denominators, that is 2 and 3. I just request you, do it once, you will love it. Instead of saying, half and 1/3, these 2 are 2 unlike because the denominators are different. If you say because the size of the objects are different. So I have 1 apple of half size in my left hand, another apple of 1/3 size in my right hand. If I show these 2 apples, half-sized apple and 1/3 sized apple, to students, and if I ask them, these 2 apples are unlike apples. Can you guess why? These 2 apples are unlike apples. Can you guess why these 2 are unlike? Because the size of the apples are different. 1 apple is of half size, another apple is of 1/3 size. It is not because the denominators are different, the fractions are unlike. It is because the size of the objects in that collection is different. That's why the fractions are unlike fractions. Denominators is a trick, is a way to identify. It's just a way to identify, but that does not give you the concept. So see it from that point of view. I would say, one more question. When we say, like to add 2 unlike fractions, we take LCM. We teach students what to do, take LCM. How to do, how to take LCM. We tell them the procedure. We tell them we give them we have already given them the programming, the sequence of programs to find out the LCM. But my question, one question is, think about it on your own. Can we add 2 unlike fractions by taking HCF? We have been teaching students find out the addition of the sum of 2 unlike fractions by taking LCM. My point is, can we find the sum of 2 unlike fractions by taking HCF? Try it on your own, but just one hint for you. HCF and LCM, these 2 are directly related concepts. LCM and HCF, these 2 are directly related concepts. If LCM is there, HCF is definitely there. We need to find it out, Okay, so connecting to real life, one example. I'm moving a bit faster because the time is running out. So this is just, I asked my child, do you know symmetry? What does it mean? So these are, I found the beautiful, the easiest real life example, which every child must have seen, must have noticed. So the example of symmetry in the life, right? I asked him, what does it mean? He was not able to explain it. Then I asked, can you give me an example? He gave me an example and the example was correct. I asked him again, can you give me 2 more examples? He gave 2 more examples which were correct. Then one thing which I understood, the child has understood the concept but is not able to speak up, explain it. So if a child is not able to explain, it doesn't mean the child does not know the concept. Keep this in mind. Second is, I'll not go with that. This one, very important. This was a question which was asked to one child, is to arrange the these three fractions in ascending order, in increasing order. The child had written the answer which is on the screen in red color. So 1/9, 3/9, and 4/5. I avoid reading it when I introduce the concept fraction. I do not read it as 4/5, 4/5. That gives misconceptions. So in initial introductory classes, so I say 4/5, and then if I have to add, so 3 more fifths, how many fifths? 4/5 and 3 more fifths, so 7/5. 3 halves and 5 halves, how many halves? 8 halves. 1/3 and 9/3, how many thirds? 10 thirds, right? So that way, so reading it mathematically will help to a large extent to help children overcome with the phobia and all. So this is what is the answer that the girl has written. Now, when the girl was, this answer is correct. When the girl was asked, how did she perform this and reach to this answer? What she replied was surprising for us. She said, because 1 is smaller than 3 and 3 is smaller than 4. So 1/9 become the smallest and 4/5 become the largest. Now see, it doesn't mean if the child has given you the correct answer, it doesn't mean the child, knows the concept. So my point is, let the child speak up if you are there, if you have time to, give this opportunity to child. So if it is happening in the classroom, one child will speak, others will also be listening. So in that case, what we need to do, we need to go beyond the way we have been marking, correcting, ticking mark, or crossing out the answers correctly or incorrectly. We need to go beyond that, and we also need to see the logic whether the child has used correctly or incorrectly. Maybe a child has to an extent given you the correct answer. The answer maybe is wrong, but to an extent the child's logic was correct. So in that case, what we need to do is to understand the assessment, the pattern. We need to look for the consistency in the patterns of a child's answer. Why does it happen? One edition, a child has done correctly, and the second edition or another edition, some has been done incorrectly by the same child in the same examination. So it means there is something that we need to see for, because our examination pattern, our assessment does not look for the logic of the child. It looks for only the answer or maybe some steps, if it is required. So we look for what they have done incorrectly. We do not look for why it has been done incorrectly. So if you look for that, you will be able to understand the exact area of improvement, and you will be able to make it very much interesting for your students. These are quickly 1 minute on this. I have spoken a lot about this. So this is how do we need to introduce concepts. Start with experience, ELPS. So let the child or the students experience the concept with physical objects, with concrete objects. Second comes spoken language to describe the experience. You describe and you encourage the child to describe the experience that he or she has while using the objects. Represent their experience through then pictures. That many of books you have seen them nicely. Then fourth, generalizing their experience through written symbols. Then fourth stage here you see comes is the symbols. So 2 + 3. But the language comes at the second level, and if you really practice this, you will find students, they will not be struggling further with the word problems, and they will find it very interesting. Mental maths has a huge importance. Do it a lot. I say 5 minutes every day. It will help you to a large extent. So with all these, I would say thank you so much, the teachers. And I have something for you on the screen. You can, yet I had many things. So this is like the feedback. For the feedback, we request you for your valuable feedback before we end the session. Please, you can find, if you have a scanner, barcode scanner, you can scan this, or otherwise Bipin will keep on posting the feedback, the link for the feedback in the chat box too. So you can click on that link and fill the feedback form. And I would say keep your mathematical eyes open, if you keep your mathematical eyes open, you will be able to see, identify the patterns in the nature. You will be able to identify the mathematics in your surrounding. You will be able to identify the concepts are everywhere in your, surrounding, and you can relate it while teaching in the classroom.
Thank you, Rick, sir.
Vivek ji,
Yes.
there is a small request.
Yeah.
In your Q&A, that is question and answer section, at the
Right.
bottom of your screen, you can see there are some questions. I'll be grateful if you can address those questions, please.
Okay.
There are 8
So,
questions over there.
okay, I could see only 5. No issues. I'll take some of these. I'm able to see 5. Okay. So one is about, I have a question about, unlike fraction, if you see two fractions, 1/2 and 2/4, they are unlike fractions, but their value is same. So we cannot possibly always say their value size is different. Now here in this particular question, like two fractions, 1/2 and 2/4. See, in the first fraction, there is one object and the size of that object is 1/2. In the second fraction, 2/4, there are two equal sized objects. Two equal sized objects, and the size of each object is 1/4. So when you combine two objects of 1/4, you actually make it half. It actually becomes half. What we can do, we can take some chart paper, we can use chart paper, or maybe we can take, let's say if I take one chapati of half size and two chapatis of 1/4 size. So when you join two chapatis of 1/4 size, it actually becomes, half. So then the value is same, but because a particular size has been broken into two smaller portions, the size of objects become different. So 1/4 and 1/4, two chapatis of 1/4 size, which actually is half size. How do we explain mathematically like fractions to students? So, yet fraction is something which I really love to talk about, but because, I always say any concept in mathematics is based on some previous concepts. So, like fractions means, let's say 1/2 and 3/2, right? These two are like fractions. Now, you see in one particular fraction, if I say 3/2, there are three important concepts that we need to understand. Number one, 3, which is a numerator here. Number 2, 4, which is denominator. And the third thing is, because I say 3/4, right? So 3/4 means, so 3 numerator, 4 denominator. So these are two things. And the third thing is 1/4. So let me explain it. 3/4 means, point number one, there are 3 equal sized objects. There are 3 equal sized objects. So 3 numerator, it talks about how many equal sized objects are there in that particular collection. So there are 3 objects of equal size, right? Then the second question that comes, if the objects are of equal size, then what is the size of each object? Then what is the size of each object? That is a very obvious question that comes. So then the size of each object is 1/4. So 1/4, 1/4 and 1/4. 3 objects of 1/4 size makes it the collective size of the collection 3/4. Then what is 4? The denominator. The denominator 4 is all about how many objects of this particular size, means in this case 1/4 size will make one whole object. That is 4 objects of 1/4 size will make one whole object. And that's why when 5 becomes the numerator, 5/4, then we say it is improper fraction, improper size more than the proper size. Proper size here means the size of the whole object. So that, these 3 things that we need to, and if you start it with, by taking examples, and I find Apple, and nowadays especially, Nowadays, when you are conducting online classes, you can design PPTs, you can keep the objects on the PPTs, and you can explain all these three aspects. Why only numerator and denominator? Because when we focus only on numerator and denominator, they struggle with the proper and improper, and then later on conversion into mixed fraction. And when conversion into mixed and improper fraction comes, if they struggle there, they will struggle with the decimal. Right. So that way, I mean, it's related to every concept, sub-concept of fraction. So that we can do that way. Kindly explain the fraction by taking HCF. Okay. So I have given you an example. I have given you a hint. You can try it on your own. I think you will definitely be able to do. But I just give you one more hint. So half and 1/4. Let's say these two are unlike fraction. You want to find the sum of these two fractions, right? Unlike fractions, by taking HCF. So find out the HCF of half. Find out few HCFs, let's say 3, 4 HCF, and 3, 4 factors of half, not HCF, 3, 4 factors of half, right? And 3, 4 factors of 1/4. And then find out which one is the highest common factor. So if I take half into consideration, if I find the factor of half, so half itself becomes a factor of half. Next factor of half will be 1/4, right? So in the same way, if I take 1/4 and if I find out the factor of 1/4, so first factor will be 1/4. So if you make a list of factors, 3, 4 factors of half and 3, 4 factors of 1/4. Then find the highest common factor. You will find 1/4 is the highest common factor, right? So it means half and 1/4, these are the two fractions which we have to add. So 1/4 is the highest common factor. Now, can I write half as a sum of 1/4 and 1/4? So 2 1/4. Half means 2 1/4. And 1/4 means 1/4 itself. So when you add half and 1/4, you get 3/4. So 1/4 on the behalf of 1/4 and 2 1/4 on the behalf of half. So what did we do? We actually took the HCF of those two fractions, not like when you take LCM, you take the LCM of the denominators, right? But when you take HCF, you take the HCF of the fractions actually which have been given to you, right? There is one question, vocabulary for subtraction, class 1 also, please. Addition and subtraction should be to an extent dealt simultaneously, like if you want to see want them to understand the relationship to that. Subtraction and division. If you compare subtraction and addition, if you compare division and multiplication, I think even we are more comfortable with addition and multiplication if you compare with subtraction and division. One of the reasons is because A plus B is equal to B plus A. A multiplied by B is equal to B multiplied by A. But in case of subtraction and division, it does not happen, right? It does not happen. A minus B is equal to B minus A, and B divided by A is equal to A divided by B. It is not like that. So that commutativity does not happen. So then what you could do, you could simply use the terms. So if I take away, if I take out, if I give this out, so how many are remaining? How many are remaining, right? So that way you could do. Okay, so thank you so much for all your active participation, and I hope you enjoyed this session with webinar with us. Really grateful to Ratan Sagar, the people, they really worked hard and to get this session done nicely. So thank you all the teachers. Stay happy, stay healthy. Thank you so much. Over to Bipin.